we're going to be talking about limits and their graphs. I'm just going to draw some rough sketches for this. Your graphs don't have to be precise by any means. I'm going to give you two different examples, and then we'll actually use Desmos to look at the actual graph when they give you a function and they don't give you the graph. So, for instance, let's say that my graph looks like this. Like I said, doesn't need to be precise. For right now, just looking at those examples. So actually, from the graph, we're looking at limits. So remember, a limit is where your graph is going to what y value, right? When we're looking at this, we have to look at this from three different perspectives. We have to look at it as we're approaching from the left, as we're approaching from the right, and if we're not approaching at all, what is the actual value? So we're going to look at the value of x equals 1, and we're going to approach from the left. So this is going to be 1, and to designate that we're approaching from the left, it's going to have an exponent of a negative. And then we're going to call this function just f of x. It's not actually going to have like an equation necessarily for this situation. So if I'm looking at this, if I'm approaching this value here from the left, okay, so I'm going up to that value. What is the y value there? What's it approaching? What y value? 2. You are correct. Good job. Then we'll have it approach from the right. So that designation will be with a positive because we're approaching from obviously the positive side. So again, looking at that one value, looking directly to the right of it, what's the y value there? It also happens to be at 2. Then we have to talk about the general form. So the general form, there's a criteria for this. So if the limit from the left and right are equal, then the limit as x is approaching a of your function equals that value. So kind of like, remember when we had those piecewise functions and we were looking at whether the function was discontinuous or continuous? We had to plug in that value of interest, and if those two numbers on your piecewise equaled each other, then the function was continuous. Kind of that same concept, but limits. So since the limit from the left and the right are the same value, the limit without any designation of whether it's left or right is going to be 2 in this situation. Okay? So that was a basic graph. Now we're going to get a little bit more complex graph. Again, not worried about precision on this. So we're going to look for a couple different things here. I want to find the limit as we're approaching from the left, the limit as we're approaching from the right, the actual limit without direction, and what is g of 0. So we have a lot of different things going on there. So 0 is my x value, which means I'm more concerned basically right along here, along that y-axis. Well, looking at from the left, I'm approaching from the left, and that y value is what from the left? It is a 2. Now approaching from the right, so if I'm on the right side of this, I'm coming into what y value? 0, or big old goose egg, is correct. So by default, the limit, without designation of direction, my left and right were 2 different values, so the limit actually does not exist. So we write DNE. Now the next part, which I kind of have to erase a little bit, silly fish, got in the way of my own stuff. G of 0, is that going to be at 2 or at 0? 0, because that's where my closed dot is. So even though my limit was a 2 and a 0, that doesn't mean that g of x doesn't exist for that point. It just means you need to find the close point. If they were 2 open circles, which could potentially happen, then you would write does not exist. But since we did have a closed circle, it'd be at 0. The last thing that we need to talk about is approaching a limit with infinity, and they'll give you a function. So for instance, they might give you h of x equals, they'll give you some function. Let's go with x plus sine x over x. And I want the limit as x is approaching negative infinity, and the limit as x is approaching positive infinity. You don't have to write the plus sign, you could just write infinity. Just giving you that direction. So with that, we don't know what the graph looks like, but this whole section's on graphing. So we're actually just going to graph this on Desmos or just a regular graphing calculator, either or. So I go to my handy dandy Desmos, and I type in my function. All right, there's my function. As I'm approaching negative infinity, well, negative infinity is going in this direction. So if I were to keep scrolling out here, or if I wanted to zoom out and then scroll, okay, I'm at negative 170. I can see it's going to 1.006, and if I keep going, boy, that looks like it's going to 1, and it is. So now we need to do the other direction. Okay, so I'm going to 400, or if you really wanted to, you could go in the thousands. 0.9999. All right, so okay, if I were to keep expanding this, it's probably both going to go to 1. And there you go. You have both of your limits denoted just by graphing. Otherwise, the other thing is piecewise functions, but we've already talked about how to graph those piecewise functions before and that point of interest, so I'm not too worried about those. But there, in a nutshell or a gist, is limits and how to read them off of a graph.